Welcome back to the channel, guys. So, time is not as simple as we think it is. Many of us think that time of all things in the world is absolute. That is because during our day-to-day lives, while driving home from our office or going on a holiday, we don't see any difference in the passing of time. That is, however, simply not true. Time-like properties such as velocities is also relative, which means that two clocks on a different journey through space might not match each other upon meeting. This brings us to the question, what is time dilation and how does the flow of time change? If we go by the definition, it says that time dilation is the difference between elapsed time as measured by two clocks either due to relative velocity between them or due to a difference in gravitational potential between their locations. So I assume all of you guys must have watched Christopher Nolan's Interstellar. If you haven't, then what is wrong with you? Let's take this movie example here. So in Interstellar, oh sorry, wrong clip. So in Interstellar, I'll skip all the irrelevant part here. Basically, the protagonist travels away from Earth in search of a habitable planet. He has a daughter who's like 9 or 10 years old. Since the protagonist is exposed to relatively higher gravitational fields due to his proximity to a black hole, time moves slower for him as compared to his daughter on Earth. When both of them meet again after some time, the protagonist is roughly of the same age as he left, whereas his daughter had aged to about roughly 70 to 80 years old. This is an example of the time dilation due to difference in gravitational potential between two locations as we talked about in the definition. Thus, it could be also said that time passes slower on top of a skyscraper because Earth's gravity gets slightly weaker as altitude increases, which is true in theory, but the change would be too small to be noticeable and is thus neglected. Now, let us suppose that you have a twin. Your twin decides to undertake an intergalactic voyage. Let's suppose that when he left, both of you were 20 years old. During his voyage, your twin traveled at velocities comparable to the speed of light, which is around 3 into 10 to the power 8 meter per second. Let's assume your twin traveled at about half of that. Now it would be clear to you at this time that time will move slower for your twin as compared to you. When your twin returns back to you after his long and tiring voyage, he would be surprised to see that you have grown older than him. This is known as twin paradox. The difference in time is given by this formula where delta t is change in time in your frame of reference, which is Earth, and delta t dash is the change in time in your twin's frame of reference. Also, v is your twin's average relative velocity and c is the speed of light. Since we have assumed the traveling speed is half of that of speed of light, the above formula reduces to this. Which means that if your twin returns after a period of 20 years for you, when you will be 40 years old, he will still be about 37 years old. This is time dilation due to relative velocity. With current technology severely limiting the velocity of space travel, this phenomenon is very negligible and is thus ignored. The difference experienced in practice are minuscule. For example, after 6 months on the International Space Station or ISS, orbiting Earth at a speed of about 7,700 meter per second, an astronaut would have aged about 0.005 seconds less than those on Earth. The cosmonauts Sergei Krikalev and Sergei Avdeyev both experienced time dilation of about 20 milliseconds compared to time that passed on Earth. Thanks for watching. Have a great one.